Hey guys, it's Mark from the GMAT Mentor, here to tell you about a cool technique for solving a common problem type on the GMAT, the weighted average problem. First, let's review the overall concept of weighted average. For example, a venue sells regular tickets for $20 and premium tickets for $40. If a group buys 9 regular tickets and 1 premium ticket, what is the average price? To make things easier, you might think, well, what if there were an equal number of regular and premium tickets? In that case, of course, the average would be $30, which is exactly halfway between 20 and 40. But here we have more $20 tickets, so the average is weighted towards the $20. How do we calculate that average? The standard approach is to use the average formula. The average is the sum of the terms divided by the number of terms. So to find the average here, you'd add up all the ticket prices, divide by the number of tickets. Since $20 appears 9 times, a better way to do this is to use multiplication. This gives you 180 plus 40 over 10, which then gets you to 220 over 10, resulting in $22. So that's the algebraic approach to solving, but there's a better way to do these problems. It's called the balancing approach. This approach is faster and easier than algebra, and on the GMAT, why do it the hard way? I'm going to go slow as I explain it, but trust me, in the end it's worth it and it is faster. The balancing approach is best explained visually using a balance scale. First, draw up the scale and put the two quantities on either end. Then, because there are more regular tickets than premium tickets, you can put the balance point nearer to 20. So here's the key step. Since the ratio of the tickets is 9 to 1, you can replicate that ratio in the distances as 1x to 9x. Just make sure you flip the ratio so that the shorter distance 1x goes with the bigger quantity 9. What we don't know is the ratio multiplier x. But we know that 1x plus 9x adds up to 20, and from there we can solve for x. If x equals 2, then 1x is just 2, and 9x is 18. Now we can find the balance point, calculating either from the left side, 20 plus 2, or the right side, 40 minus 18. The balance point is $22. This is the weighted average ticket price. It's remarkable that this works, but what just happened here? Let me explain. 22 is a distance of 2 away from 20, and 18 away from 40. In other words, the ratio of the distances is 18 to 2, which reduces to 9 to 1. That's the same exact ratio as the numbers of tickets. In fact, for any weighted average problem where you're averaging two quantities, the ratio of the distances from the average equals the ratio of the numbers of items. As you've seen, you can use this fact to help you solve more efficiently. Think of it like a seesaw, with the shorter distance and the heavier weight of the 9 tickets balanced by the longer distance and the lighter weight of the 1 ticket. The balancing approach can save you a lot of time on GMAT questions. Give this moderate question a try and remember to follow the problem-solving process. As you work through this question, look to use the balancing approach. Go ahead and pause the video now. First, make sure you understand the setup. It's asking for an average cost per liter, but you know it's a weighted average because there's 3 times as much of one of the substances as the other. And because there's more of Y than X, you know the average price must be closer to $49. In other words, the weighted average must be over $47. So right off the bat, you can eliminate choices A, B, and C. Let's go ahead and draw our balance scale, again with the balancing point closer to 49. Since we have a 1 to 3 ratio with the quantities, we can go ahead and replicate that ratio in the distances, just remembering to flip the 3 and the 1. Because the distance from 45 to 49 is just 4, and 3 plus 1 equals 4, there's no need to worry about the ratio multiplier. We know that the average is just going to be 45 plus 3 equals 48, or alternatively, 49 minus 1 equals 48. Either way, 48 is our average, and E is our answer. So can it really be that easy? Yes, it can, and on a moderate question like this, you can save a lot of time using this approach. Now let's try a harder example. The balancing approach is also great to use when the GMAT gives you a twist, as it likes to do. As a quick hint, in this question you'll need to work the approach backwards in order to solve. Pause the video while you take a look at this problem. Here you have another weighted average problem, only this time you're given the average and you have to work backwards to find the ratio of the number of small dogs to the number of large dogs. So again, the balance scale approach is the best way to solve this problem. Go ahead and draw your balance scale and fill in the information you know. Next, calculate your distances to the average. Now you have your ratio of 8 to 22, which reduces to 4 to 11. But remember, the average overall weight of 29 pounds is closer to the small dog's weight of 21 pounds, so there must be more small dogs. So when you replicate the ratio, put the big number 11 by the small dogs, and the small number 4 by the large dogs. Thus, the ratio of the number of small dogs to the number of large dogs is 11 to 4, and the answer is A. Note the trap answer E, which could get you if you forgot to flip the ratios. Though it is important to understand the algebraic approach, you can generally save yourself time and frustration by using the balancing shortcut. I hope you enjoyed this video. For more GMAT strategies, hit subscribe and check out my website at thegmatmentor.com.